hopefully you've got audio now. I've just had to make a couple of changes to my audio capture. For some reason there was no audio at the beginning. There's that better. So hopefully you can hear me now. That we had some problems with the audio input capture at the beginning, but it should be much better now, hopefully. So kicking off with things. So let me just get ready to go here. So if you think about the current situation that people are trying to do around their development operations, so DevOps, and the security challenges they've got, one of the key things is the actual attack surface is getting much bigger. I worked on physical machines, then into virtualization, and when we were working with physical machines, we were normally sub 10. As we moved then on into virtual machines, we were something between 10 and 100 virtual machines, or some organizations up to the early thousands. But if you're actually moving then into containers, that goes up by a factor of 10 again at least. So we're now looking at thousands of different containers that could be compromised and accessed by hackers. So that attack surface is getting much larger because of the situation as things are changing. Also, the pace of development's much greater. Back 10, 20 years ago, the development of a product would take 6 to 12 months. Now we're looking at releases within 2 to 4 weeks, and continuing that development pace through agile processes and the way that we develop. Also, what we're trying to do is include software development, the actual security in the software development life cycle as early as possible, because at the moment, we tend to be doing it as a bolt-on later, but really we need to have our security built into the actual software development life cycle and do it much earlier in that process. A lot of us are thinking about how we can do it, but still, we're having to bolt it on later depending on the technologies we're utilizing to do that. Also, we're quite tied to the infrastructure we're utilizing, so a lot of organizations are having to think about what they're actually utilizing from an infrastructure perspective. Is that on-premise? Are they using a hypervisor? Are they using bare metal? Are they using a particular cloud service for containers? And if you are, how do we actually provide some level of security for that? So there are some real challenges for a lot of organizations in the way that they actually secure that environment. Also, there's two different approaches to this. So the more traditional approach we've seen with majority of the organizations is actually focused at that container-centric approach. So looking at controlling the containers, but not the actual orchestration environment. So focusing how you can secure those individual containers and the communications between them, rather than talking about the actual Kubernetes environment. So one issue when you're doing that, when you're controlling the containers, you've got separate security controls that can actually cause issues with the orchestrator, whether that's Kubernetes or a Kubernetes derivative, some of the other technology like OpenShift, also using Rancher and those kind of platforms. You can have an issue that the security can cause issues with the orchestrator and restrict what can be deployed and how it's deployed. Also, it tends to be delivered in isolation. It's isolated to each individual container, and it's quite a manual process in a lot of cases to be actually get that security set up. And it's also a bolt-on, so we're sticking something on top. And in most terminologies, it's using things like shims, so effectively putting firewalls between containers to create that segmentation for east-west traffic, and a variety of other bolt-ons to make things work from a behavioral perspective, and also other ways that we can understand what's happening when we've actually deployed. But if we actually look at it from a Kubernetes perspective, and we actually look at it in context with that Kubernetes environment and actually use some of the native controls within it, it gives us a much more tightly integrated solution from a security perspective, which also allows us then to create a more automated security platform, and also make it more scalable, because we're not adding any additional software into that environment other than some of the monitoring capabilities. We're actually utilizing Kubernetes itself for a lot of that security. So It's very scalable, and it's also very fast because we're not taking away any of the resources that could be used to run the workloads. It's also then built into it, so it doesn't matter where we operate it, as long as it's a Kubernetes environment. It doesn't matter which namespace, which cluster, which environment, whether that's a public cloud environment or an on-premise environment. It's going to provide us that same level of security and that automated, scalable and fast delivery of it. So let's have a think about some of the use cases, and normally we start off looking around that visibility piece, and as an organization we want to know what we're actually utilizing. Commonly when we're looking at visibility with a traditional security product, we're looking at what we've got in production. We're not looking at what we're actually doing in test and dev and what we're doing in the development environment and part of our DevOps process as we move forward with it. But some of the key things we're interested in is understanding what images have been utilized, understanding if they're actually hardened images. We need to understand what clusters are being used, what namespaces and the nodes across that. So identifying the whole of our environment, how it all fits together. The other thing we were looking for is vulnerability. So we're looking to understand those particular image and containers and also the Kubernetes environment, what level of vulnerability we have. A lot of people are still using like CVE to actually go off and understand where the vulnerabilities lies and doing a lot of things manually. Whereas really what we need to do is to actually bring in a level of automation so that we don't have to go manually and check every container, every image, and ensure that we've got no vulnerabilities in those particular images that we're utilizing. The other thing, compliance is becoming a big area. So understanding from a CIS or NIST or PCI or even HIPAA or equivalent to HIPAA in the UK with health records and patient records, whether we're actually being compliant with the specific security needs that we need in that environment. And it's sometimes hard to be able to do that, and we pay consultants a very large amount of money to actually come in and look manually across our environment and audit it to understand where we've got gaps in that compliance. We also need to think about the configuration management, and that's the configuration of the containers and also the orchestrator environment, so Kubernetes or derivatives, and understand what's happening there, because we may have ports open, we may have other things, other services or specific levels of privileges that shouldn't be allowed within some of those containers and also the general Kubernetes network environment as we move that across. We also need to consider the network segmentation. So we don't want containers communicating with other containers that are not required to communicate. How do we ensure that we've got this east-west management and also north-south as well, because we don't want some containers that don't need internet access or external access being given external access. So one, being able to understand that visibly and see what communications are set up, but also have the ability to control that, especially if we can actually use Kubernetes network policies to do that, because we don't need any additional software and we don't need any additional configuration to make that work. Plus, if we migrate it somewhere, so we move it from a test and dev environment into a production environment, it comes across automatically with all those network policies built into it, so making sure that we're compliant from a network perspective. From a risk profiling perspective, we also have to consider things like what the vulnerabilities, but also prioritize the rankings from a risk perspective, because a particular image workload and the vulnerabilities within it, when we're utilizing that in a development environment or specific ports that are open for us to access those containers to do work and monitoring, are less of a risk in a dev environment than they are in a test or when they roll into production. So understanding where those containers are being operated and the vulnerabilities allows us then to prioritize that risk ranking, so we can focus on things that are important and deal with other things at a later stage, because none of us have the time to do everything we need to do at the same time. And also finally, when we've actually rolled these into production, we need to be able to look in at detection for issues and also looking at any response that we've got for that. things like baselining and understanding, the behavioral patterns of a container or a set of containers, and also looking at those native Kubernetes controls, and also priorities and what level of access those particular containers have got. So if we see things like a change in behavior, something like writing files or changing where it's communicating, we need to be able to detect that and respond to that as well. So if you think about, across those three areas, so we're building out our workloads, we're deploying our workloads, and then we're running our workloads, we have a number of environments that we could be utilizing. From a Kubernetes perspective, it could be a standard Kubernetes environment. It could also be OpenShift, which utilizes Kubernetes from an orchestration perspective underneath a slightly different UI. It could also be one of the public cloud offerings of Kubernetes from Amazon, Google, or Microsoft's Azure platform using AKS. So it doesn't matter where the actual workloads have been deployed or being built. It can actually utilize StackRox to provide a policy engine, and also using the API integrate with other components of it. So this means we can actually build, deploy and run in any cloud environment, any hybrid environment, or on-premise, depending on what you choose to do as an organization. And we're seeing organizations doing a mix of all of these. Some, if they're really security conscious, they're doing on-premise only. Some are doing a mix in a hybrid environment, and some have got a cloud-first policy. But the key thing is integration with all of the other things that that you're utilizing within that build, deploy, and run environment. So at one end, we need to be looking at image scanning and then looking for which images are being utilized, and also making sure what vulnerabilities are within those images as well. So StackRox itself has got its own image scanner that comes along with the platform, but you can actually still utilize one of the existing tools like Anchor, Claire, Key, or Tenable if you're utilizing those at the moment, and just hook it into the solution. But also, it integrates into your CI/CD pipeline and tools that you're utilizing, such as Jenkins and Travis CI and those kind of CI/CD tools. So you don't need to change the way that you're deploying and building your infrastructure. It just tightly integrates into that using the StackRox API and built into the Kubernetes platform itself. From a runtime, whether you're running Docker or Creo, no problems there. It will work with either of those environments. And then from a DevOps notification perspective, it works with all the standard tools that most people are using, such as Jira, Slack, and PagerDuty, and other communications technologies. So we can actually give feedback to the developer community to show, what changes need to be made and what risk levels there are within the workloads as it goes through that cycle. Couple of statements from customers of StackRox, just to give you an idea of what people are saying about it. So Informatica, a lot of companies talk about solving the same problem, but it's how you do it that matters. By integrating with Kubernetes, StackRox makes it so security is built in, not bolted on. And I think that's quite a key thing. That integration and built in rather than bolted on makes a big difference, especially when you're really rapid with your development, and you need to be able to know that your security is a part of what you're doing. Another one from the CISO at Splunk: after testing the other solution, we found that StackRox was the only solution that was Kubernetes native, enabled us to build security as code. StackRox was the clear choice for our security and DevOps teams. So again, a very large development company, Splunk. A lot of people are utilizing Splunk, especially for their security platform and monitoring all their infrastructure, and using Splunk as a repository and a way to identify behavioral and patterns within their issues within security. So just to give you a picture of how it's deployed, there is a one central platform, which is the main UI where you go into and log in to actually understand what's happening. Each of the nodes has a collector on it to be able to collect data, and each of the cluster has a sensor on it. utilizing those components. It doesn't matter where you deploy your containers, it will actually be able to pick up, identify risk profile, and also look at compliance for all of your workloads wherever they reside, whether that's in public cloud, on premises, or a combination of the two. A few current customers, just to give you a picture. So there's a lot of organizations utilizing it. I briefly covered Splunk on there, but organisations such as Homeland Security in the UK, so the Department of Homeland Security have got a real issue about security in their infrastructure. IBM Cloud are utilising it to manage workloads that they're utilising there. Northrop Grumman, who are a big driver within the security space and cyber security, utilise StackRox as well, and some other people like YourPay, Zendesk you may know of as well as Johnson Controls. So what we're trying to do and how we're trying to protect your cloud native applications, it's trying to give you the ability to innovate faster and have less friction within the security side of things, because a lot of times your DevOps teams are slowed down by the SecOps teams in the way that they're trying to secure the environment, and also security can be circumvented by the DevOps team, or trying to get through without the SecOps guys slowing them down. So there can be an issue between the two departments there, and what we're trying to allow is to keep a high level of security, but also integrate between the DevOps and the security teams to make sure that development can be done in a secure way and deployment into production can be done in that way as well. We're also trying to eliminate risk before applications are launched. So looking at it actually through the process of development, understanding the images that have been utilized, understanding the code that's been deployed, looking at compliance around PCI and other compliances like CIS and NIST will help us when we actually go to launch that application without having issues later to circumvent. Also, we're trying to ensure consistency by applying security policies that can be applied then anywhere. So wherever you're deploying those workloads, those security policies can be applied. One way to see how this works in your environment is to do a proof of concept. And a proof of concept can be done within 1 hour. And we're not joking with this. So what we can do is designate a particular Kubernetes cluster for the evaluation. Like I said, there's only 3 components to install. They come in directly from the standard repositories, so you're just going to install them effectively as containers. Once they're up and running and installed, around about 15 minutes, it'll start assessing your environment, and 15 minutes later you can actually have a look and understand what the risks are and use that risk assessments to identify either gaps in your current security infrastructure, or to fix problems that you might have that are outside of your current infrastructure from a security perspective. But let's have a think about this context of this Kubernetes environment and some of the cases that we're going to get. One of the key things around the image is identifying vulnerabilities, looking at the registries we're using and the packages that have been driven from those registries. We want to look at the clusters. Let's compare between. Sound is low for me, I've been told. So let me see if I can just increase my volume quickly on here. Maybe a second while I do that. Just going to get across to my settings. Won't be a second. Bring up the audio input settings and trying to increase maybe the gain on there. I'm just dropping a few bits in, won't be a second. And is that better? So I've just increased the gain on my audio, so I think it was Rani was saying that the audio is a little bit low. Can you hear me more clearly now, Rani? So I can't increase the gain there. Let me see if I can. Increase the gains elsewhere. Volume inputs. I'm just going to push the audio up a little bit more. A couple of dBs. See if that improves things. So, is that a little bit louder for you? I've not seen anything come up yet, so hopefully you can hear me a little bit better now. Is that a bit louder? Ah, good. Right, so we'll carry on then. So, looking at the clusters, one of the things we need to do is consider, what the clusters are being used for, and also, the BUs that are involved in that. Are they being used for test, or are they using for production? If we understand that, it makes it easier for us then to understand what the risks are and be able to prioritize risk better if we're in that situation. Also, we need to look at the criticality of the applications and also responsible dev teams, because we may have different dev teams working on different applications. By being able to annotate and label those workloads, it helps us understand who we need to notify if there are any particular issues in there. Also, we need to look at the privileges and the host mounts and also service accounts that are set up and identify what the levels of risk we've got there, but also look for changes in them as well. Part of our detection process, we need to understand if the privilege has been increased or things have changed with any running workloads. Also, we need to consider API keys, crypto material secrets and cloud disks and anything else being utilized by those applications. Again, one, from a vulnerability perspective, but secondly, when we're actually in production, to actually identify if there are any attacks going on, so we can detect and react to those attacks as well. Also, from a network perspective, we're going to look at internet reachability, understand the communication paths between each one of the workloads. We don't need containers having communication paths to each other when they don't need to communicate. It's one of the key things we need to in security is lock those down and do that level of microsegmentation that we're doing there. Also, we need to, on a detection side, need to understand if processes are being launched, what active connections there are and if those connections are changing, what route are those connections taking as well, again, for us to understand where problems are arising from that. So having a quick policy engine that leverages the Kubernetes data, because when you're launching your Kubernetes workloads, you're utilizing JSON or YAML files, and what we can do is use those as a base point to derive the information about those workloads, look where the images are, which repository they're coming from, use the scanning tools, and also identify the network configurations for each one of those through those YAML files. And it allows us to get that better, richer context on what's happening within that environment. So a few use cases. I'm going to go into each one of them quickly just to cover off, but we're going to look at visibility, vulnerability management, compliance, network segmentation, risk profiling, configuration management, threat detection, and also incident response. So if we look at it from a visibility perspective, we want to be able to see everything we've got in our environment. We want to understand, what images we're running, what nodes and clusters are made up of, and what we've deployed into those environments. And we need to see that quickly so we can understand exactly what's happening out there. We also want to be able to quickly find any violations. We want to be able to identify any of these that are critical, any of these are warnings, so we can focus our efforts at the critical issues and understand what's happening there. StackRox itself has out of the box 300 security controls and best practices, especially around compliance and things which we'll cover a bit later, so we can identify things quickly and look for problems that are existing there. We can also then identify things like suspicious processes, configuration issues, network policy details that shouldn't be in place, and also do it in context of what type of environment it is, whether it's a test and dev environment or a production environment. From a vulnerability perspective, we can use the StackRox scanner, or you can use your own scanner and just incorporate into the solution. Make sure that all your images are correct, and we can actually look through and identify any issues and also the severity of those. So it allows you to quite quickly look and find and deal with those situations. But also having a powerful search capability, we can actually rapidly pinpoint and identify vulnerabilities in any active deployment. So we can look for specific things we want to do and look what policies have been applied to those. We can also then tune, build, deploy policies to de-risk the situation and reduce those vulnerabilities as we go forward. From a compliance perspective, if you're running PCI, which a lot of financial organizations need to be PCI compliant, or if you need to meet any of the others, such as the CIS benchmarking for Docker or Kubernetes, it's quite easy to utilize StackRox to identify where your compliance is actually outside of the specific control, so you can deal with it really quickly. So it'll pinpoint specific things for you, so you can go in and identify those particular areas where you're out of compliance and deal with them quickly. But it also allows you to look at compliance through that development cycle, from the build and testing of your workloads through into the deployment of them into production. So as you go through that process, you can start early on to identify if there are any issues around PCI compliance, HIPAA or the UK equivalent of HIPAA, to actually make sure that you are being compliant before you deploy into production. StackRox has developed some standard controls for this, and each one of them is ties to each specification for compliance. It makes it easy for you to identify them. Plus, you can also add in your own additional compliance standards if you wish to as well. But it allows us then to look across all of the namespaces, nodes and deployments to identify any workloads that are not compliant within that your infrastructure. So, segmentation. So a lot of people are utilizing third-party tools to create effectively shims, or utilizing mini firewalls to actually put between each one of the workloads that you've got in your environment. But one of the key things is to identify them first. So understanding which containers and pods are communicating and to whom. But the next thing is be able to then identify which ones need to be able to communicate, and for those that don't, apply some policy which then can be applied across all of the environment, rather than having to manually set up processes for network segmentation for each of your containers, allowing you to actually put a policy together and have it defined against those YAML files when you're deploying. Allows easier segmentation of your workloads, but also utilizes the actual native networking capabilities within Kubernetes to actually deploy that segmentation policy, rather than having a third-party piece of code in there. So, like the last piece there, it provides security as code. So as you're developing your workloads and you're deploying your workloads, they inherently become more secure because of the way that you're actually going through that process. Risk profiling is really important because you need to identify where the risks are, but also have an understanding of which are the most important ones, the ones you must fix now, the ones you can leave till later, depending on the level of risk, so the particular vulnerability that you've got, but also where that vulnerability is. If you've got a vulnerability within a development environment that's an isolated environment that no one can get to, it's less of a priority than having a vulnerability within a running production environment that's got internet access. So having that priorities and working through those priorities helps you ensure that security is applied where it needs to be, rather than trying to fix everything in one go, which is going to be impossible, especially with this very agile development process, which makes it very, very difficult for us to keep up with securing the environment. On the configuration management, there's a lot of things we need to do and manually do today to actually ensure that builds are secure. So looking for particular services that shouldn't be running. So things like SSH daemons running within containers shouldn't be there when they're deployed in production. But actually, a lot of times we've got to manually check for those through the development and test and roll into production environment. By having this configuration management and saying that only these particular services and these particular configurations can be utilized in, say, a production environment, ensures that as it goes through, that policy is applied and you don't end up with insecure services being allowed to be running within a production workload. And you don't have to go and look for them, because you can feel comfortable that you've already done that as you've built out your policies and roll those into production. So really key for that. And also using things like tagging allows us to understand which production, whether it's in production or test, as it moves through that process. And you can utilize your CI/CD pipelines to automate that process, and the actual security comes along in line with that, because it's integrated within the Kubernetes environment. We also then need to look at threat detection. So once you're into production, we need to be able to then identify if there are any issues there. Looking at all the running processes in those active deployments, leveraging rules and whitelists to detect anomalies in behavior. So something's starting to read or write data more than it would normally do, its privileges have changed, its access and network policies changed. We need to be able to identify that. We need to also minimize the noise, because alert fatigue is a real issue. And a lot of organizations can't see the problems because they've got so much noise. So be able to minimize that noise and focus on the areas that are most important, looking at those high severity issues, is a critical thing. Also, understanding process execution. Are we starting to run different processes than we would normally have in that particular container workload? So looking at the behavioral changes, looking at those network flows, looking at escalation in privileges, and also files that might be launched in there. Again, allows us to identify them and also show those through the UI, but also notify directly out into whichever security platform you're utilizing to identify them and also escalate them. That incident response, we need to be able to enforce it. So within the platform, you can go through enforcement and you can set automation against that. You can either alert or block a particular communication path, but also you can integrate directly with whatever SIEM tool that you utilize for your security management, so that it all ties together nice and neatly, and also all of your security issues are identified and notified quickly, so you can go in and do that. You can manually apply policies later, or you can automate the process of applying those as you go through it. Hopefully that gave you a bit of a picture of what can be done. I'm not saying I'm a complete fully engaged with all the things that StackRox can do. I'm learning myself. But what I've seen so far from the environment is that it makes life